Hey everyone, I'm Josh Wright, and I'm working with Nate Walter, and for our final project, we decided to work on traffic shaping.
So what exactly is traffic shaping? Well, our definition for traffic shaping is managing bandwidth between certain machines, processes, and/or protocols. Essentially, what it is you can have certain kinds of traffic coming through, whether that's from a certain machine or a certain process or a certain protocol, and your router can either prioritize that traffic or sort of deprioritize that traffic to kind of like arrange a queue of the most important kinds of traffic to let through, and it will allow those more important things to take up more of the bandwidth. So it's important to note that whenever you prioritize one kind of traffic, you're always going to be limiting another kind of traffic. And either one of those things can be sort of the default all traffic in general that's not under any other specified rule. And there are reasons why you might want to have the default traffic either be prioritized over certain other kinds of rules or limited under more specialized rules.
All right, so we've talked a little bit about what is traffic shaping. We're going to move on to some of the use cases of traffic shaping before we talk about our project itself and what policies we were able to implement. So here we've got three use cases we think that where traffic shaping could be used in the real world. The first being voice over IP. So obviously in audio calls and voice calls, it's essential that we don't drop the call, we don't lose certain packets, and prioritizing this information on the network when it's around, when it has those bursts of traffic, that is important. So that I think can be a good use case for implementing traffic policies. The second is an in-house server that has guaranteed bandwidth. So no matter what else is going on in the network, you can be assured that there will be a consistent amount of bandwidth allocated, and the traffic for your server and whatever it's hosting. It may be hosting important information that will be available at all times. And then the third use case is limiting YouTube streaming, limiting other types of streaming as well. I think this is a very common one. You can see it at businesses, at schools, where certain non-essential traffic is limited in favor of that which is more essential to the organization. Okay, now quickly I'll just go over some of the edge router configurations. So we are using the edge router X's, the Ubiquiti edge router X's that were given to us, that were used in class. And as we were implementing traffic policies, there was two basic ways of doing that. The first being through the GUI, through the user interface, the Edge OS, and this had a sort of quality of service tab, which enabled us to go over a few different queues, which could create traffic policies, and we'll go over them a little bit on the next slide. And then the second being the command line interface, also through the Edge OS, but this was allowing us to run much more specific and more customizable policies. It seemed the better route, definitely, and we had a little bit more success actually using the command line interface. It was a little bit tough finding some instructions and code online, but I think we were able to get that working pretty well. Okay, so here we're getting into a couple of the queues that are found in the GUI in the user interface. There's just a couple of them here that we're going to talk about, although there was a third that we didn't get into too much. First being the smart queue. The smart queue is the most abstract, the most general traffic shaping policy creator. This one allowed you to select an interface and then limit upload and download speeds. It also had the ability to add some advanced options. You could limit burst speeds and things like that, but overall is a very general queue type. And the second is called the basic queue, which was a lot more specific. It's called the basic queue, a bit of a misnomer. This one you could select certain IPs, but also networks, and you could apply limits to applications as well, meaning games or streaming certain types of traffic. And there you could limit the rates. You could also choose the different queue types, which was just different algorithms which would allow you to change the queue order and how exactly things are being allocated and ranked.
So there are a few different things we tried to do with this project, some of which we succeeded at, and others we kind of got lost in the configuration of the edge router and weren't able to quite figure out. But the first thing that we tried and succeeded to do was essentially just pure bandwidth throttling. So what we did was we put a traffic shaper on the entire network, just to really lower our entire speed a lot. And I believe that this slide, the screenshots from the speed tests, are from this test actually. You can see here the first one is clearly from the throttled connection, the good old 1.95 megabits per second download. And that one on the right is what the syslab typically reaches around when it's not throttled. The second thing we did was we did different ports on the switch. That was relatively easy to set up using the basic queue, or was it the smart queue? Actually, either one. I think with the smart queue you could do specific ports, or the basic queue you could attach an IP to a machine. Either way, there's two ways to do that. And this one, we set it up so that if there was another machine on the network that was trying to use the internet, then it would throttle the second machine's bandwidth. So what we did was we ran two speed tests, just two different machines on the same network by themselves, and they both got the same result. And then we ran them both at the same time, and the one we wanted to be throttled saw a significant decline in speed. The other two things we tried to do, which ended up being unsuccessful in the end, were traffic shaping by using specific apps and by using specific protocols like HTTP. There were settings for both of these in the edge router, both in the GUI and the CLI, and we tried a lot of things, but unfortunately we weren't able to quite figure that one out. I actually ran a test with downloading a ISO image using both torrent and HTTP at the same time, and there didn't seem to be any significant difference from what it was normally doing. So our test did not work in that case. But these things are possible to do. Perhaps with some more time we could have figured it out, but we just never really got to figuring that one out. So that essentially kind of wraps up this presentation. So thank you for listening, and hope you have a good day.